On August 2nd, 2027, the moon will completely cover the sun for up to 6 minutes and 23 seconds. Daylight will collapse into an unnatural twilight. Temperatures may fall, bright planets may appear, and the sun's hidden atmosphere will spread across the sky like white fire. But despite viral claims, this will not be the longest eclipse ever. Longer totalities have happened before. An even greater one is waiting in the future. So why will this eclipse last almost 3 times longer than the total eclipse of 2026? The answer requires a larger-looking moon, a smaller-looking sun and Earth moving beneath the shadow at exactly the right place. First, a correction. The 6-minute eclipse happens on August 2nd, 2027, not 2026. The August 12th, 2026 eclipse is real, but its maximum totality lasts only around 2 minutes and 18 seconds. Less than 1 year later, the 2027 eclipse will keep the sun covered for almost 3 times as long. 6 minutes may not sound extraordinary, but during a total solar eclipse, every second changes the sky. As the moon covers the sun, daylight takes on a cold, metallic appearance. Shadows become unnaturally sharp. The final sunlight passes through valleys along the moon's edge, creating Bailey's beads. Then one last point of light forms the diamond ring, and suddenly, the sun's bright surface disappears. The corona bursts into view around the black moon. Pink solar prominences may glow along its edge. The horizon can resemble sunset in every direction. For a few minutes, the human eye can see structures normally hidden beneath the sun's overwhelming glare. And in 2027, that moment will continue unusually long. The first advantage comes from the moon. Its orbit around Earth is not a perfect circle. Sometimes it is farther away and appears slightly smaller. At other times, it moves closer and appears larger. During the 2027 eclipse, the moon will be near perigee, the closest part of its orbit around Earth. That difference matters. If the moon appears too small, it cannot cover the sun completely. A bright ring remains visible, creating an annular eclipse. But in 2027, the moon will appear noticeably larger than the sun. Its shadow will be wider when it reaches Earth. And because the moon's disk must travel farther before uncovering the sun again, totality lasts longer. Imagine sliding one coin across another. The larger the front coin appears, the longer it completely hides the coin behind it. A small change in distance creates a major change in darkness. At the same time, the sun will appear relatively small. Earth also follows a slightly elliptical orbit. When Earth is closer to the sun, the solar disk appears slightly larger. When Earth is farther away, it appears smaller. In 2027, Earth reaches aphelion, its farthest point from the sun, on July 5th. The eclipse occurs less than 1 month later, so the moon will appear unusually large while the sun appears relatively small. The difference is subtle to the eye, but during an eclipse, tiny differences in apparent size determine whether totality lasts seconds, minutes, or does not happen at all. The final advantage comes from Earth itself. The moon's shadow races across the planet, but Earth is rotating beneath it in the same general direction. Near lower latitudes, Earth's surface moves eastward faster than it does closer to the poles. That means the ground partially travels with the shadow. Imagine one fast train overtaking another train, moving in the same direction. The faster train still passes, but the process takes longer. The 2027 eclipse crosses relatively low northern latitudes. Near maximum eclipse in Egypt, the sun will stand more than 80 degrees above the horizon. The moon's shadow will strike the surface almost directly, creating a path roughly 257 kilometers wide. Together, these conditions reduce the shadow's speed relative to observers and push totality beyond 6 minutes. This is not one object standing still in front of another. The moon, Earth, and sun are all moving. Totality is the brief result of those motions lining up. But 6 minutes and 23 seconds will not be visible everywhere. The moon's central shadow will begin over the Atlantic Ocean before reaching southern Spain. It will then cross parts of Morocco, Algeria, Tunisia, Libya, and Egypt. From there, it will cross the Red Sea, parts of Saudi Arabia and Yemen, and continue across the Horn of Africa. The calculated point of greatest duration lies in Egypt, where totality reaches approximately 6 minutes and 23 seconds. Observers near the center of the path will experience the longest darkness. Move closer to the edge and totality becomes shorter. Outside the path, the eclipse will remain partial, and this corrects another viral exaggeration. The entire world will not go dark. The deepest shadow will cover only a narrow corridor across Earth. Much of Europe, Africa, the Middle East, and parts of Asia will see a partial eclipse. But even 99% coverage is not totality. A thin, uncovered edge of the sun is still bright enough to hide the corona and damage unprotected eyes. 6 minutes is extraordinary, but Earth has experienced even longer darkness. The 2027 eclipse will not be the longest ever. It will not even be the longest total eclipse of the 21st century. In 2009, totality reached approximately 6 minutes and 39 seconds. The 1991 eclipse lasted 6 minutes and 53 seconds. And in 1973, darkness continued for more than 7 minutes. These events are closely related. They belong to the same eclipse family, known as Saros 136. A Saros cycle lasts approximately 18 years, 11 days, and 8 hours. After that interval, the Sun, Moon, and Earth return to similar geometry, producing another related eclipse in a different part of the world. This family peaked in 1955 with totality lasting just over 7 minutes. Since then, each returning member has grown shorter. The shadow path is slowly shifting, changing the angle at which it crosses Earth. That does not mean total eclipses are disappearing. It means this particular eclipse family has passed its maximum. Even so, after August 2nd, 2027, Earth will not experience another total solar eclipse lasting longer until June 3rd, 2114. For generations, this will be the benchmark. The ultimate record is still ahead. On July 16th, 2186, totality is calculated to last approximately 7 minutes and 29 seconds. NASA identifies it as the longest total solar eclipse in its 10,000-year catalogue, covering the period from 4000 BCE to the year 6000. The remarkable part is not only its duration. Scientists can already calculate where a shadow will cross Earth more than a century from now. Clouds remain unpredictable. Celestial mechanics do not. For scientists, 6 minutes provides more than a longer spectacle. To the unaided eye, the sun's brilliant surface normally overwhelms the faint corona. During totality, the moon acts as a natural occulting disk, blocking the bright surface and revealing structures close to the sun. Researchers can study coronal streamers, magnetic activity, the sources of the solar wind, and changes in Earth's atmosphere as sunlight abruptly disappears and returns. 6 minutes gives instruments more time to capture images, repeat measurements, and collect spectra. A longer eclipse does not automatically guarantee better science. Weather, equipment, and location still matter, but it gives researchers an unusually wide observing window. There is one rule more important than every duration in this video. During all partial phases, the sun must be viewed through proper solar viewers that comply with the ISO 12312-2 standard. Ordinary sunglasses are not safe. Cameras, binoculars, and telescopes require solar filters secured over the front of their optics. Only during complete totality, and only from inside the path of totality, can the sun be viewed directly without protection. The moment any bright part of the sun returns, eye protection must go back on. On August 2nd, 2027, a larger-looking moon, a smaller-looking sun and Earth rotating beneath the shadow will combine to create more than 6 minutes of totality. Not across the whole world, not for everyone inside the partial eclipse region, only for those standing inside one narrow path. For them, daylight will fade, the corona will appear, and for up to 6 minutes and 23 seconds, the hidden atmosphere of our star will replace the daytime sky. It will not be the longest eclipse ever, but no longer total eclipse will occur again for nearly 87 years. For most people alive today, August 2nd, 2027 may be the longest totality they could realistically witness. Would you travel to another country to experience 6 minutes of totality? Tell us in the comments. Like the video and subscribe to SciQuest for more extraordinary events already written into the future of our sky.